All right, so we looked at iOS Firewall. Next, we're going to look at the zone-based firewall. Zone-based firewall handling things a little bit differently. iOS Firewall, looking at our earlier setup that we had, the general settings on the iOS Firewall, having it set where we have some interface setup, we have some inspections, we have some ACLs. From a basic management perspective, if you just have a couple interfaces, it's not so bad. When you get into situations where you have more and more interfaces, it generally gets to get fairly cumbersome as far as managing individual ACLs, individual items on interfaces, and being able to structure things out as far as what traffic is being allowed or not allowed. In our last example, we just had the two interfaces looked at, looking at a basic setup with inspection on one of those. Now, moving on further, getting into deeper types of options, deeper types of items being looked at, can run into additional problems with having multiple interfaces because of having to keep track what, say, routing protocols are running on a certain interface or what other items may need to come in and terminate on an interface. So zone-based firewall, looking at things a little bit differently, looking at things with the concept of zones. So rather than just looking at a particular interface and saying, okay, I'm going to put this access list on this interface and this access on this interface, grouping interfaces into zones. So with these zones themselves, second here. The zones themselves being grouped, so I can have an inside zone, an outside zone, possibly a DMZ zone. Different names for those could be public and private. You can name them pretty much just about anything you'd like. Concept then being that individual interfaces being assigned to individual zones. So the individual interface is assigned to the zones, and with that information, then having policies set up for how traffic is passed, what traffic is or is not allowed to pass between different zones. We're going to start off looking at some rules, and we're going to look into some configuration examples as well. Starting off, we have some rules determining how traffic is passed, what traffic is or isn't going to be passed or allowed from one zone to another. So looking at our rules, we have a rule: these zones must be configured before the interface is assigned. If we're going to assign the interfaces to a particular zone, we do have to have those zones configured first. Pretty straightforward, logical. So we have a basic zone definition. Beyond that, each interface can only be assigned to a single zone. So if I have an interface on my device, my FA00 interface, that can be inside, that can be outside, it can't be both. An interface is only in one zone. If I had an interface that I wanted to be, say, in a DMZ, then I would have a separate zone. I'd call that DMZ, and then I can do other policies for what traffic is going to be able to pass to that interface itself. As far as traffic for the interfaces themselves, the next rule we have: all traffic to or from an interface implicitly blocked except traffic to or from the same zone and traffic to an interface on the router. So if I have two interfaces and those interfaces are both, we'll say, in my private zone, then traffic between those interfaces, networks routed via those interfaces, that traffic can all pass freely. If I have traffic terminating on the router, traffic destined, I want a telnet to my router, I can connect telnet to my router from anywhere, because that's traffic to an interface on the router itself. Not traffic passing through the router, but traffic to the router that's going to terminate on that router interface. Again, that next one beyond that, interfaces in the same zone, traffic will flow by default. So if I have two separate zones, traffic from one to another is going to be blocked implicitly. If they're in the same zone, traffic will flow by default. So if I take my zone-based firewall and I put all my interfaces in the same zone, all my traffic is going to flow. If I put all my interfaces in a different zone, if I have my fast Ethernet in one zone and my serial in another zone and another connection in another zone, then by default, traffic between those interfaces, coming in one interface, leaving out another interface, is going to be blocked. So different general rules, zones themselves, and we'll get into how the policies are constructed to work around these things a little bit here. So the general rule, if I'm within the same zone, I can pass just fine. If I'm passing to another zone, then that gets into what my policy says. The next rule we have regarding the zone interfaces for traffic going to or from one zone to another, it needs to have a policy either allowing or inspecting traffic. We'll get into the policy items in a little bit, but two separate policy items have an action of pass and an action of inspect. With an action of inspect, he's inspecting that traffic, building his state information, and allowing return traffic to come back. With an action of pass, he's just allowing the traffic out. He's not building a state table for return traffic. Some people think if they just pass in one direction that the return traffic is automatically going to be allowed. That's not the case if I'm just passing the traffic. If I'm doing the inspection, then I would allow the return traffic back. So the next set of rules we have, additional rules, general information. With the device itself, we have the concept of a self zone. So the self zone is the interfaces of the router itself, interfaces to a router interface itself. So if I have my router's FA00 interface, FA01 interface, serial interface address, traffic destined to the router itself, by default, is going to be openly allowed. Now you can get into policy to change that, but in general, traffic to a router interface is going to be allowed. So if I have, we'll say my serial interface is my outside zone and my fast Ethernet is my inside zone. If I'm connecting from the other zone to my router's physical interface address, I'd be able to connect and say telnet or whatever on my router. If I'm trying to pass traffic through and out the other interface, that traffic would not be allowed. That traffic would be subject to the interzone rules. Next rule we have is about traffic between a zone member and a non-zone member. So the policy and the passing of traffic is only from zone members to zone members. So if I have my inside interface is in a private zone and my outside interface is in a public zone, and I have a third interface that's not applied to a zone, even though I could be receiving routes and receiving information, I'm not going to pass traffic from, say, my public zone to a network on that interface or reachable by that interface that is not in a zone. So my device may have routes, but he's not going to be passing that traffic through. Get into some other things you can do for that in a minute as well. Now, interfaces not assigned to zone are considered classical router ports and could be configured for CBAC. So if I have 4 ports on a router, I could have 2 of those ports set up and say these 2 ports are doing zone-based firewall, and in different 2 ports, those 2 ports could be doing CBAC. Other than that, generally you can't mix and match the 2. So you can't mix and say, I want to do CBAC and zone-based firewall on this interface. It's one or the other. So if I had a situation where I had different devices and I had 4 interfaces and 2 just wanted to do zone firewall and 2 wanted to do CBAC, I can do that. But again, because I can't pass from a zone member to a non-zone member, I couldn't pass from the 2 zone interfaces to the 2 non-zone interfaces. Different restrictions there. So the next item we have, if an interface is not part of the firewall, may need to put it in a zone and configure a pass all policy. So again, if I had a new interface being added on, if I didn't have other specific things being told what to do with that interface, but I need to pass traffic out that interface, I have my public and private zones defined, and I bring on a second fast Ethernet port that's learning routes and learning some networks. If I want to pass traffic to those networks, I would need to put that into a zone. I could put it in one of my existing zones, or I could put that into a new zone and just configure a policy to allow that traffic to that particular item. So those are the general rules, and those are also listed in the documentation, covered in the documentation. Good to have a general background as far as what traffic is going to be allowed or not allowed, understanding what the default behaviors are for the zone firewall. We're going to get to an example here in just a minute. If you have any questions, go ahead and type those in the Q&A box. So general configuration steps. Some of this is similar to other things we've looked at, similar to the MQC type policies, similar to other policies. Class maps, policy maps, and service policy. The difference being where those are set up and where those are assigned. So we have class maps matching our traffic, policy maps matching the classes and setting up an action for those. We have zones defined, zone pairs, and service policy applying the policy to the zone pairs, as well as having the interfaces assigned to the zones. So regardless of what our policy is, how our policy is configured, if that's not actually assigned, we don't have actual interfaces assigned to that zone, we're not actually running the zone-based firewall. We're going to go ahead and take a look at a brief example here, and then go ahead and make some changes and take a look at different options that we have. All right, so for our zone firewall example here, we're going to start by looking at a similar setup to what we were doing earlier with our iOS firewall, and similar restrictions allowing the TCP, UDP, ICMP traffic coming into that frame relay interface if it was initiated from router 4, so watching traffic coming through that device. We're going to start on router 1 here. Just going to go ahead and remove our inspection. We're also going to take off our access group. Pulling up our configuration here. Again, we still have our other inspection rules defined. We're just leaving that config in there for now, but it's not applied to the interfaces themselves. The configuration in there, not physically applied to the interface. Removed our access list and the inspection rule off the interface itself. In this case, we have our two interfaces we're looking at, the FA00 interface, as well as the serial 00.12 interface. We're going to go ahead and set up our policy. So working through our basic information, basic items that we have. Start off with our zone policy here. Again, so starting off working on our steps, first we're going to define our zones. For the scope of the lab exam, you may be given specific zones to use, you may not. Again, we're just going to do a basic zone definition here. We're going to go ahead and define our zone security. We're just going to call these private and public. We've got our basic zones defined there. We're going to have a zone pair. And we're going to put our zone pair with our class map and our service policy. So we're going to go ahead and start with our class map. Those of you that are familiar with class maps, fairly straightforward. In this case, getting into inspection. So our class map is going to be a type of inspect. Now, for our traffic itself, we could have individual classes for these items, or we could put everything in the same class. Beyond type inspect, you have different options. You can put in match all or match any. You can also put in the specific item that you're inspecting. In this case, we're going to go with a match any. Doesn't matter because we're just going to group these three individually, and we're going to start with all this test. And we're just going to match our three separate types of traffic. Match protocol TCP, match protocol UDP, and match protocol ICMP. We've matched different protocols in our class map. Next, we have a policy map. Again, our policy map type of inspect. Matching our class. So we have our class map defined, we have our policy map defined, our class map matching our traffic, our policy map matching our class. Next, we're going to go ahead and define a service policy. Service policy is going to bind our policy map, in this case policy map being bound to the zone pair. We're going to set up a zone pair. Now, with these zone pairs themselves, a zone pair is for one direction. So in this case, I have a private and I have a public zone that I had configured as my two zones, zone security public, zone security private. If I want to do traffic from my private to my public, that is one zone pair. So in this case, I'm just going to call this, we'll say R4, R1, implying the general direction here, and we'll say R4, R2. You could call it A to B, public, private, whatever you'd like. And then with that, you have for your zone pair what the source is. In this case, my source is private, and my destination is public. I have my zone pair defined. I have it named R4, R2, source private, destination public, and with that, applying my service policy. So I have my service policy applied to my zone. Now in this case, my zone is defined, my policy is set up, but it's not actually applied anywhere because I don't have my interfaces themselves assigned to the zones. So on my interfaces themselves, FA00, zone member security private, my serial interface, zone member security public. Now starting with my basic configuration here, basic setups, what I've done, I set up a class map, having my individual items. Again, I could have those protocols in separate class maps, or I could have them all in the same one. My section here was not restrictive in either direction, so we went ahead and put them all in the same one. We'll come back to other things we can do with that in a little bit here. Policy map, matching that class, and then the zone pair to apply the policy. Again, zone pair being specific to a direction. So as mentioned before, traffic normally by default without a policy configured is not going to pass from one zone to another. So I have my one zone being where router 4 is off my FA00 interface, zone member security private. My other zone being the interface connecting to router 2, zone member security public. My zone pair policy that I have configured, source private, destination public. So it's in the outward direction from router 4 to router 2. So my policy is inspecting traffic in that direction. Now, because my policy is doing the inspection, then the return traffic would be allowed back through, return sessions would be allowed back through the firewall. We're going to go ahead and take a look at that here. So moving over to router 4, we go ahead and telnet to router 2. That appears to be unsuccessful. See if we can figure out what's misconfigured here. Router 4 has a route for that. Verify that router 4 can connect to router 1. We'll start with some ping connectivity here. We can ping through to router 1, and our traffic's not passing through our policy here. Let's look at our policy again. Anyone see what's wrong with the policy, why it's not passing traffic? We mentioned our policy options and different things we can do. We have our policy defined. We have our class matching the traffic. However, what we don't have is an action specified for our class. We need to make sure we have that in there. We have our policy map here, our class type inspect. Have an action specified again. We can inspect, we can pass. We can get into other nested types of policy with another service policy there. In this case, we are going to go ahead and do an inspect. I'm going to try our connection from router 4 again. Able to ping through. We're going to go ahead and try telnet as well. Establish our session through. And go ahead and take a look at our policy here. And our policy name was POL. And our zone pair was R4, R2. Back our syntax here. So looking at our policy here, show policy map, type inspect, specifying our zone pair, R4, R2. And also going to go ahead and look at the sessions for that. In this case, showing that we have a established session. In this case, established session for the inspection. Established session connecting in. Destination port there, TCP23. We also have traffic as far as what traffic was seen for that connection. Go ahead and kick off some more traffic here. Tech support's a good command to get some traffic flowing in a telnet session. Go ahead and kick back to router 1 and take a look at our sessions now. We see a lot more traffic being sent. Again, the responder being that traffic being sent by router 2 returning that traffic. We have our other individual items here, individual protocols being matched, sessions being matched, looked at. Again, in this case, looking at items, in this case, seeing that as a TCP. We're going to go ahead and adjust our policy here as well. Some of the syntax is slightly different. I show commands, in this case, show class map type inspect. Go ahead and remove the match protocol TCP. We're going to add in a match protocol telnet. Go ahead and set up another session here. Went ahead and just broke out of that session. Establish another session to router 2. Get our connection information on router 1. Now in this case, the newer session that we have, showing as telnet. Again, the inspection looking at that traffic, seeing that traffic as telnet because we had the match protocol telnet specified. Also taking a look at what we had on router 4. Go ahead and exit this connection. We did still have a port mapping. So if we look at our other connection, try and connect on port 3030. Back to router 1. Again, showing that connection on 3030 also as telnet. Zone-based firewall does use the same port mappings, PAM configuration that we saw for CBAC. In this case, being able to have things mapped for a different protocol, in this case, based off of our other configuration that we had. Pull that up here real quick. Our other port mapping configuration we had, in this case, we were looking at port 3030 for the 150.1.2.2. In this case, we were looking at specifically with an access list. Again, we're not doing the other inspections, but the port mapping information is still used by the zone-based firewall. All right, so we looked at having an inspection policy. Next, we're going to look at adjusting that. We're going to change our policy a little bit. And we're going to change that to pass. In this case, get an error message. If we have an inspect item configured, we need to remove that first. We're going to try to just check from router 4. Now, in this case, a telnet action not being allowed through. And if we try and ping, again, we see him sending traffic. We look over at router 2. Router 2 is sending out the echo replies. Router 2 is trying to send that traffic through. Because the policy is just set to pass and it's just allowing to pass in the one direction, that return traffic not being allowed through. If I look at my sessions here, I do see matches. I see matches for the ICMP. If I look at those are incrementing. So I had 19, here I have 22. Here I have 25. Again, showing my action of pass, showing what my total is for packets and bytes. But because the pass is just unidirectional, just allowing that in that particular direction. The different options I have, I could allow it to pass in either direction. I could configure a second policy. So we're going to go ahead and just add in a second policy here. And I'm going to just do a separate class here. Just call it ICMP. And a separate policy, call it policy 2. Policy 2 I'm going to use for the traffic in the opposite direction. In that opposite direction, I'm just going to take that ICMP traffic and allow it back. Pass here. Now, just having that policy configured doesn't do anything. I need to bind that policy in. So in this case, I need a separate zone pair. Exit on my policy configuration mode. Okay, this is the direction R2 to R4. In case my source is the public zone, my destination is the private zone. And my policy of Hall 2. Again, my zones are already set up. My interface is already in the zones. So having this policy set up here should be sufficient. I did have a pass action configured. I switch back to router 4. If I try and ping, that ping traffic allowed because I'm allowing it in both directions. Now in this case, if I try to do a telnet to router 2, my telnet succeed or fail? Any votes for either? Whether it'll work or it won't work? Okay, so I try my telnet here, see what happens. In this case, my telnet not working. Because the telnet not working, because it's just allowing the traffic in the one direction, traffic in the return direction not being allowed through my policy. We're going to go ahead and adjust the policy slightly on router 1. And on my policy, I'm going to take my test policy, and from that one, I'm going to remove the telnet. And looking at my policy there, I'm going to slightly modify my policy map. And I'm going to take my class test, change that back to inspect. I'm also going to add in a class of ICMP and change that to a pass. In this case, what I've done is I've taken the ICMP out of the other test group and put it into its separate class here. So I have the class type inspect for test doing the inspection, class type inspect for ICMP doing a pass. And what this configuration is going to do in conjunction with this other policy for the traffic still matched by that test class, my UDP and got the wrong here. TCP back in there. So for my test class, my TCP and UDP traffic, I'm going to go ahead and inspect that from private to public based on my inspect policy here, the POL that was applied in my private to public, my public to private direction. For the opposite direction, it's going to be affected the other way there. So take a look at my policy here again. My policies and my zone pairs. So I have class map test matching TCP and UDP, class map ICMP matching ICMP. For my first policy, inspecting for the test, which is the UDP and TCP. For ICMP, having a pass. For my second policy, having a inspect for ICMP with a pass, so the ICMP class being a pass action, and no action configured for the TCP UDP. So my first policy with the source private destination public, so from the R4 to R2 direction, in that direction I'm inspecting TCP and UDP traffic because I'm inspecting those would allow that return traffic. In the opposite direction, I have a policy that is for ICMP that ICMP is just going to pass freely. So ICMP itself, I'm allowing to pass freely. The other traffic, TCP, UDP, I'm allowing to pass freely from router 4 direction to router 2. If I switch back to router 4, my telnet session should be effective now. So I'm now able to establish a telnet session. Looking at my configuration on router 1. Yeah, buffer there. Showing that telnet session, opened very recently, again connecting to router 2. ICMP still having a separate class. I switch back to router 2. I have that class there, so I could do it in either direction. My policy information again here. Because I did see my ICMP packets pass freely. So another question came up, what if you have subinterfaces? Well, with subinterfaces, you're still dealing with logical interfaces. So it's not going to automatically inherit a zone definition. A zone definition needs to be on each logical interface. So in my example here, I do actually have a subinterface on router 1. So the serial interface does happen to be a subinterface. Wherever you have your IP address assigned as your logical interface, that would be the place you would have the zone member. We will get into a couple other cases later in the week. You can get into situations where you have things like virtual templates. If you have a virtual template, you can assign a zone member on a virtual template. And then when that virtual template was cloned for a connection, then that connection would be part of that particular zone. But in this case, if I was doing some other connection on my main serial 00 interface, that could by all means be in a different zone, having a different zone defined. If I just put a zone member statement on my serial interface, it's not going to automatically grandfather in all these sub-interfaces that are there. All right, so looking at other items that we have here, we've got our policy set up, a couple different actions we had. We're going to look at some of the other actions, some of the different types of things we can do. We looked at the port mapping and how the port mapping integrates with the zone firewall, similarly to the iOS firewall or CBAC configuration, where it can get into doing port mapping for individual ports or groupings. We're going to go ahead and adjust our policy here a little bit. Now, in this case, we had set as pass. Looking at our options here, we do also have an option of pass and log. We're going to go ahead and turn logging on this particular setup. In this case, logging on the policy, which is traffic from router 4 going out to router 2. In this case, that was just done on the ICMP class, so it's not all our traffic. We're just going to look at some log information. We're going to go ahead and clear our logging. From router 4, I'm going to go ahead and just kick off another ping here. Off a ping there, move back to router 1. In this case, we show that we have traffic. Take a look at our log. And logging to the buffer so we can keep track of those. And it gives us information about what he saw, the target and the class. The target being the zone where that was configured. I'm sorry, the zone pair. Our zone pair was R4, R2. The class being the specific class of our policy that was matched. It's a class named ICMP. So showing the traffic, showing what it did. So showing it said pass that traffic, pass that packet, due to the pass action that it had in the policy map. So being able to look at those items, again, you could be given specific output. You could be given output and told that the logging should look like this. So in which case you would be able to deduce from that what your class name or what your zone pairs should look like. You could be asked, what is this traffic? Given a bit of code, what is actually being passed, where it's being passed, who to who. In addition to that, additional information here on ICMP 8 and 0, getting into other ICMP code information. Different items there listed in that message. And again, in this case, saying 5 packets passed from 4.4 to the 12.2, type 0, type 8 information. Now, additional information we have, we looked at being able to set up information on our passing. So we did a pass with a log. We can also get into additional inspections. So setting up inspection information. So for our, switch back to router 1, which is where we are. In this case, taking a look at our policy. Look at our POL policy. Our POL policy for our class test is inspect. We're going to go ahead and take a look at what other options we have there. With pass, we had an option to log at the end. Inspect, it gives an option for a parameter map. So a parameter map allowing us to do additional deeper inspection type items. We're going to go ahead and exit out of here and set up a parameter map. And we can call this whatever we'd like. I'm just going to use test. It doesn't have to match class name or policy name. I'm just happening to call it test. We'll call it test 2. Now looking at the options you can do within your parameter map, what do we see? Well, we see a lot of these similar types of things we saw with the other settings for TCP intercept and for the CBAC. Being able to set on alerts, being able to turn on audit trails. So we're going to go ahead and just set some of those up. We're going to do alert on, audit trail on. We could have timeout values for ICMP. In this case, we don't have ICMP in this particular class. So that really doesn't apply. Our particular class here is matching TCP and UDP. So looking at our TCP options here, we have, again, idle time, fin wait when the connection's ending. We're going to go ahead and just adjust the idle time here. And we're going to drop that down to, we'll say, 6 seconds. Fairly low value. And we'll say the UDP idle time of 6 seconds as well. So we have our parameter map we created called test2. We're going to go ahead and apply that to our policy. Clear our logging. Off another connection from router 4. Taking a look at our logging information. Again, shows our session started. Also shows our session stopped there. Again, because we had a relatively short timeout value, having it stopped our TCP session after a fairly short period of time. So if you are doing things like idle session times, you may want to be careful about what values you pick. But again, looking at what traffic's seen in that particular time frame, go ahead and just bump that up just a little bit. In this case, looking at the other values that we have in that parameter map. Again, most of those just kicking to other defaults. I'm going to bump up the TCP idle time here a little bit. Off another session. Able to log in. Look at our logging information on router 1. Logging information again here showing our new session started. Look at our zone information. If we throw that one in the buffer here. In this case, looking at our zone information, traffic we've seen. In this case, seen a lot of traffic responding back. In this case, looking at the show check, a lot of traffic coming back on that particular session. When it was created, last heard from, so affecting for the idle time, when that's going to disconnect and drop off. Again, some of these other miscellaneous types of things, having max and complete set, low values, high values, same for the 1 minute values. Again, similar to the CBAC settings or the TCP intercept settings. Again, those are thresholds that would need to be crossed. UDP idle time, ICMP idle time, DNS timeouts, 0 being giving it more time if you want to restrict and have a fixed time for a DNS return, set that to a different value. Fin and SYN for the connection starting and stopping. So how long you're allowing things to gracefully close for the fin or for the initial SYN connection when it's first starting up. There's also an option for max and complete host. A similar option on TCP intercept, basically looking at max and completes to a specific host, as well as just being able to set up a explicit maximum of sessions. Again, 0 is not limiting for sessions. A variety of different items there, different things that can be configured, different things that can be done. In this case, looked at a fairly straightforward example. A couple little things we changed along the way. In this case, looking at a basic example, connecting from router 4 through the zone firewall, connecting through to items on router 2. Looking at the other items we have configured. Again, quick review here of the zone itself. We have the zone definitions, zone security set, name of private, name of public. We have the class maps for the type of traffic that we want to match. In this case, looking at UDP, TCP, and ICMP. You can get into having multiple items specified. Again, if you do, make sure that you do have it specified as a match any. If you try to do match all and have both UDP and TCP, you're not going to have traffic that matches both of those. There are some cases where you might want to use a match all. I could have, say, an access list and also be matching on telnet. So I could have an access list matching traffic to router 2's addresses and also a match protocol telnet. And I would be matching traffic that matched both of those if I had to match all. So I could be looking at just telnet traffic to router 2 and have a separate one with just a match protocol telnet to match other telnet traffic. Beyond that, we have the class maps matching the traffic. Policy maps, what am I doing with that? Different options you have. Passing, if you want to log that information. In this case, my session stopped there. Kicked off my little logging message as well. So having the policy map, what am I doing with the individual classes? What are my actions to do? Again, make sure you have an action specified, action of inspect or action of pass. As we saw earlier, if you do not have an action specified, even though your class is defined properly within your policy map, you're not telling it to do anything. That traffic ends up getting dropped. For the other traffic, in the other direction, have a separate policy. Now, in this case, we had two separate zones. And with the two separate zones, we had two separate policies. One from my private zone to my public zone, one from my public zone to my private zone. In this case, if I didn't want to allow the ICMP in this other direction, I wasn't doing a pass, I wouldn't need the second zone pair. If I'm just doing the first zone pair, if I just have this first one here, I just have the R4, R2 zone, then I'm allowing traffic to pass. I'm allowing my return sessions that I see in my state table. But beyond that, I'm not allowing traffic in the opposite direction coming into router 4. If I want to allow traffic coming into router 4, again, that's a separate direction, and that gets into having a separate zone pair defined there. So with that separate zone pair defined, able to do in the opposite direction. Now, other things to be aware of, in this case, we did have a 2-zone setup. Other things to be aware of is what happens if you add in, say, a third zone. So if I had another interface on router 1 connecting off another fast Ethernet interface, another serial interface or sub-interface, I could potentially have a third zone. Now, with a third zone, I may have potentially up to 6 different zone pairs. So if I had a third zone that was, say, a DMZ zone, I would have my private to my DMZ, my public to my DMZ, my private to my public, my public to my private, my DMZ to my private, and my DMZ to my public. So the number of zones increases. You do have a potential for an increased number of zone pairs. In this case, with just this 2 zones, we have a maximum of 2 zone pairs here, 1 in each direction. So looking at the other connections we have, looking at another connection on router 2. From router 2, if we try and telnet to router 4's loopback 151.4.4, it is unsuccessful. Due to our other policy, though, we do still have the ability to ping that address. And yes, as someone mentioned, that is a pass issue because I don't have anything configured on that policy. It's not allowing me to telnet through to router 4. My policy, I do not have a policy in that direction. My policy in that direction is just passing ICMP. It's not doing anything with TCP and UDP. In case TCP 23 would be what I'd be using for telnet. Now, looking at other items, looking at my interfaces themselves, switch back to router 4. My address here, the .14.4. I'm unable to ping router 4, but I am still able to ping router 1. I'm also able to still telnet to router 1. Now, in this case, I'm able to telnet to router 1, even though it's that interface on the other side in the other zone, because it's an interface on the router itself. Again, this goes back to what we talked about a little bit earlier of the concept of the self zone. So the interfaces of router 1 themselves, even though those interfaces are designated as part of a zone, if I'm going to the address of itself terminating on that router, I'm still able to connect. In this case, the addresses interfaces of the device themselves exempt from those zone rules. So other miscellaneous questions that people may have, other common questions that come up. One gets into still being able to do other policies. Just because you have a policy between zones, you can still have other things done on your devices. You can still have access lists on interfaces for the scope of interaction with a zone firewall. With the iOS firewall, we saw that we had a strict ACL, but the state table was looked at and those ACL entries were bypassed. Traffic would still be allowed to return. With the zone-based firewall, that is not the case. So if you have an ACL that's on the interface and I have an inbound ACL that says deny any, it's not going to allow any traffic through regardless of what the policy says. So your ACLs, if you do have other ACLs on the interface, generally are more open and not as restrictive because the zone firewall itself is not going to dynamically do anything with those ACLs on the interface. Now, in this case, we did just have this zone set up. In this case, if we switch back to router 1, as mentioned, we did also have the concept of the self zone. We're going to go ahead and look at what happens when we adjust things with the self zone on the router. All right, so we have a self zone. The self zone is predefined. It basically deals with any of the interfaces on router 1. So we're going to take a look at something really quick here. Copy this off. So normally with the zones and the zone pairs, we mentioned that traffic to the device itself is not going to be affected. So in this case, telnetting to router 1's loopback, router 1's loopback is not assigned to any particular zone. In this case, normally you can't pass traffic from a zone interface to a non-zone interface. In this case, getting around that because it's terminating on the router itself, it's traffic destined for router 1 itself. We're going to start looking at stuff if we adjust things with the self zone. We're going to start by defining a zone pair. And we're just going to go ahead and call this R2 self. And the source here is going to be the public zone. And the destination is going to be the self zone. Now we're going to set up a policy for that zone. In this case, we're going to just use our other policy, our policy 2. Now we have a policy assigned for router 2 to the self. So from that public interface coming in to the self zone, Again, we just have it named R2. It's not specific to router 2. Anything coming in that serial interface, because that interface is in that zone, is what's going to be affected. Switching back here, try to telnet. And again, before my telnet session was allowed, now my telnet session is not being allowed. Trying to connect to router 1. Break that connection and take a look at what happens with a ping. Now the policy that we applied was our policy 2, and our policy 2 was allowing ping traffic. So we can still ping that interface. We can still ping the other interfaces on router 1. To look at what happens from router 4. We can ping to the 150.1.14.1, his interface there. And we can also verify that we can ping his loopback as well. See what happens when we try to telnet to one of those. Now in this case, router 4 coming in on a different zone, able to telnet to that interface. So some slight restrictions, things being a little bit different with dealing with the self zone. So router 2 being in a zone that had a policy configured for the self zone is going to affect that traffic, what's being allowed to that device. Self zone, again, referencing the interfaces of the device itself. And on router 2 itself, able to ping addresses. But if we try to telnet, in this case not being allowed. Now the telnet here, even though we're telnetting on that same serial interface, that's where router 2 is coming from, that serial interface is not considered as part of that. The interface address itself is not configured part of that zone for the interface. The interface itself address is considered part of the self zone. So because we have a policy set up for our self zone on that device, it's going to affect that being allowed. So if we switch back to router 1, take a look and see what happens if we try to apply the other policy. Over to policy 2. Okay, so our telnet is still not working. So looking at the policy here that we have, I'm going to modify this policy and set up a separate policy so we keep policy 2 there. Meant to do policy 1, so we're going to switch back to that. So we get a couple error messages here. One error message we get is that we have another policy map already attached. The other error message we get is that the inspect failed. So with a policy map to the self, not liking the inspect in the service policy. So if we want to do something to the self zone, doesn't like the inspect keyword being there because of how it's handling that traffic. In this case, we're going to go ahead and just set up a new policy. Call this SP for self policy. And going the class type inspect test, which is our TCP UDP, and it's going to go ahead and say pass and class type ICMP, and setting that to pass as well. With that other policy applied, we can now see that we're able to telnet to the device itself. That session. Policy map. Type inspect. There are two self sessions. Again, able to see what traffic was sent, traffic being passed for those. Again, because we're looking at the policy with the pass itself, just seeing the total counters, not getting other session details. With the inspect, getting other session details as far as existing connections, source port, destination port information included. Any other questions on the zone firewall? Different policies, policy options?